Okay, now we're going to add horizontal and vertical translations to the sine graphs when it moves around the graph. We've already talked about how A is our amplitude and how 2 pi divided by B gives us our new period. Now we're going to deal with when we have adding and subtracting inside and outside the parentheses. So first, we know from the past that anything added or subtracted inside the parentheses is a horizontal shift. What we're going to call that in trig is a phase shift. So you're going to hear that term. Just like transformations we did earlier this year, if you are subtracting inside the parenthesis, that means you're going to move right. If you are adding inside the parenthesis, that means we're moving to the left. So in general, to find the phase shift, and this is going to be a little different than what we're used to, so that phase shift is going to be the opposite of C, and again, that opposite is just to deal with the fact that subtraction means you're moving right, and you have to divide that out by B. So the phase shift is the opposite of C over B, and that's going to be your new starting point for the graph. On the outside, whenever you add or subtract, just like when earlier this year, that's where we're going to have our vertical shift. And this one is as you'd expect. It's a plus, that means you're moving up. If it's a minus, that means you're moving down. And there isn't anything extra with that, so whatever that number is you're adding or subtracting outside, that is how far you are moving up and down on the graph. So now we're going to do a few examples just to get you an idea of how to put all of these pieces together. Okay, so we have a couple more pieces we're looking for now. Overall, there are 5 transformations we should be on the lookout for. So first, we check for reflection. There is not a negative being multiplied by sine either inside or outside this function, so there is no reflection. Next, our amplitude. You should always have a number for the amplitude. In this case, this whatever is multiplying by the trig function. So that is a 3 for our amplitude. Next, our period. Right now, there is nothing inside, so technically that's just a 1 times x. 2 pi divided by 1 is just 2 pi. Next, we have a vertical shift. This plus 1 is outside the function because there are no parentheses there, so that's a vertical shift, which means this graph is going to move up 1. And we don't have anything being added or subtracted inside the function, so there is no phase shift. So here's where I've been talking about the top, middle, bottom idea. We have a vertical shift of up 1. So that means our new middle of our graph is going to be up here at y equals 1. Now our amplitude is 3. So from that new middle, the top is going to be 3 above that, which will be at 4. The bottom will be 1, 2, 3 below that, which will be at -2. So you can see we kind of made ourselves a little grid so we can easily be able to graph this. Now, this didn't do anything with my period. We need to label our axes. The period is 2 pi, which are our normal labels. Half of 2 pi is pi. Half of pi is pi over 2. And that third label is 3 pi over 2. Same labels on both sides. Now we just need to have the graph. There isn't a phase shift, so we're still starting on the y-axis. Sine starts in the middle. There's no reflection, which means we go up for the first point, back to the middle, bottom, middle. So you can see if you kind of create those 3 dotted lines in there to show you where your graph is going to be, you don't have to think much about the amplitude and the vertical shift once you get graphing. And there's your graph for that sine function. So we're going to follow the same process each time as far as looking for all 5 transformations. So in this graph, again, there is no negative outside or inside the function, so we're not going to have a reflection. The amplitude, there isn't a number out front, so that means the amplitude is just 1, like a normal sine graph. Period. Again, we don't have a b value there, so it's essentially like there's a 1 there. 2 pi divided by 1 is 2 pi. Our vertical shift is the number outside the function. So this means we're going to have a vertical shift of up 2. And now for the phase shift, This is inside the function. So phase shift is always c over b. So in this case, our c is pi. Our b was 1, which means we just have a phase shift of pi. Since it is addition, that means we're moving left pi. Again, when I wrote it out earlier, I said it was opposite of c over b. So that way you can think of the phase shift as we're going to start at negative pi. Another way to think about it. So now it's just a matter of putting our graph together. Our period was 2 pi, so these labels will be the same as the one on the previous slide. Again, same right and left. Here, vertical shift is up 2, so that means our new middle of the graph is up at 2. From there, amplitude is 1, so the top of the graph is going to be 1 above 2, which is 3. The bottom of our graph will be 1 below 2, which is 1. So now here's the added part. This time we have this phase shift of left pi. That means we are starting our graph at negative pi. So you can kind of draw yourself a little dotted line there. Maybe just stick an arrow on the top of the graph so you know where to start. Now we just follow the pattern. Sine starts in the middle. So now we're starting at this negative pi. And then we still start in the middle of the graph. From here, we follow our same pattern. So sine goes up first, which means that negative pi over 2 will go up to the top. Then we'll come down to the middle, bottom, middle, and just keep following this pattern until you get to the end of the graph. When you have a phase shift, you're going to do more than one round, or sometimes less than one round to get to the end of the graph. And now just do the same going backwards. So bottom, middle. And just connect that graph the whole way. And if you have any questions while I'm graphing these, make sure you write them down in your notes so you can ask me tomorrow. So now one more to do. And this one's going to mix a few other pieces in with it. So first we need to go through, list all of our transformations. For reflection, there is a negative on this too. So that means yes, there's a reflection. Which means instead of going up first, the graph is going to go down first. Next, our amplitude, the number out front of sine, so we have an amplitude of 2. The next part is the period. This time we do have a b value. B is equal to 4, so our period will be 2 pi divided by 4, and then just reduce that to be pi over 2. In this case, we do not have a vertical shift. There's nothing being added or subtracted outside the function. And then for our phase shift, here's where we have a little extra math to do here. We have to do c divided by b. And keep in mind that 4 is technically a 4 over 1. So as we do that math, we have pi over 2 times 1 over 4. And we'll get pi over 8 for the phase shift. Now we just need to look at the sign. It was a minus pi over 2, which means we are moving right pi over 8 in the end. And if you want to think of that opposite of c over b, that means we had a negative pi over 2, which is what in the end means we're going to start our graph at a positive pi over 8. Now it's just a matter of getting all of our labels. Our period was pi over 2, so that's what's going to go on the two ends. Half of pi over 2 is pi over 4. Half of that is pi over 8, which means the third spot is 3 pi over 8. Same going the other direction. Now we just use our amplitude of 2. We don't have a vertical shift, so the middle of the graph is at 0, top of the graph at 2, bottom of the graph at negative 2. And then this phase shift of right pi over 8 means we are going to start our graph at pi over 8. So now just putting our basic sine graph in. Sine starts in the middle, so we're going to start at pi over 8, 0. Because of that reflection, that means we're going to go down first when we go to the right. So pi over 4, negative 2. Back up to the middle, to the top. And connect those dots, and now just go backwards the other direction. And there's our sine curve.